Assalamualaikum and good day. We are from Group 2. My name is Nau Shafura and I will me and my friends will explain about control system experiment 1. So in this experiment we are talking about transfer function. So we will skip to our MATLAB. So for in our in the question we have to specify the m, c and k value by ourselves. So I choose 0.01 as m, 0.14 as c and 0.4 as k. So when we run the simulation, we will get this graph um, that are based in our transfer function. So I will pass to my group member to explain more about our report.
For part B transfer function, we get three results from three dam, which is over dam, under dam, and the critical dam. So here I have choose one of our result from under dam to explain about the characteristic of system transient response. So from the result we get, I have labeled each of the characteristic of system transient response that found in the graph. First of all, we can see rise time at the starting point of the graph, which is rise time means the time required for the waveform to go from 0.1 of the final value to 0.9 of the final value. The second one is peak time. Peak time means the time required to reach the first or maximum peak. The third one is overshoot. The overshoot means the amount that the waveform overshoot the steady state. And the next one is settling time. Settling time means the time required for the transient damp oscillation to reach and stay within 2% of the steady state value. So the next one is steady state error. It means the difference between the input step value and the final value. And the next one, steady state response, is the behavior of a circuit after a long time when steady condition have been reached after an external excitation. And the last one is transient response. It means the response of a system to change from an equilibrium or a steady state. That's all from me. Thank you.
07. Question 2.3 is compare the result with the theories for overdam response, transient response between theories and simulation. Maximum overshoot MP is equal to 0.0066 for theories and for the simulation is 0. The rise time is TR in second. Theories is 0.6775 for the simulation is 8.2308. Settling time Ts in second is equal to 0.571. For simulation is 14.8789. The theories calculation is damping ratio is equal to C over 2 multiply with square root mk is equal to 0.14 over 2 times with square root 0.01 times with 0.4 is equal to 1.107. For the natural frequency is equal to square root k over m is equal to square root 0.4 divided by 0.01 is equal to 6.325. For the maximum overshoot MP is equal to E power of minus pi times with damping ratio divided by square root damping ratio square root power of 2. We insert the value is equal to 0.00066. The MP in percent is equal to MP multiplied with 100 is equal to 0.066%. The rise time PR in second is equal to pi minus cos power of -1 damping ratio divided by natural frequency times with square root damping ratio power of 2 minus 1. Inside the value, it will be 0.6775 second. The settling time Ts in second with 2% tolerance is equal to 4 divided by damping ratio time with natural frequency is equal to 4 divided by 1.107 times with 6.325 is equal to 0.571 second. The rise time and the settling time, there is big difference between theories and simulation. That's all from me.
Okay, Assalamualaikum. My name is Alif Azhan bin Abdul Rahman. My matrix number CE200182. Today I will present for 2.4, where 2.4 2.4 study the transient response by adding a transfer function to the system, where I use this diagram, and I apply it to the Simulink. And the thing, we need to see the response of the transfer function, and the transition response. So we can see the end of the graph is it on a steady state. So yeah, it transition response. Okay, that's all from me. Thank you.
So the conclusion that we can make from this experiment is, for the main finding, the Simulink simulation of the transfer function in figure 1 shows that there is a steady state error between the input and output values. The steady state error is reduced in figure in 2.4 due to the addition of the feedback mechanism. It demonstrates that by adding a feedback mechanism to the system, so we can enhance it and eliminate the steady state inaccuracy. So, for the recommendation for future experiment, we hope that this experiment can be improved in terms of concept, goal, and objectives in order to learn more about Simulink and its multifunctional feature. Further experiments can be carried out in the lab, as this lab experience had to be carried out via online platform by using software, and there are some issues in communicating and observing the investigation finding. Studies on the address on a specific accuracy, the creation of new theory, or a study of the problem discovered in this experiment should be carried out in the next experiment. Thank you.